Hi, so this session is an introduction to linear functions, and what we mean by linear functions is looking at linear graphs and also equations and working between the two. So our first step is to understand what we mean by a linear equation. Now linear, a key word in there is line, okay? And we know what a line is. A line is simply a straight line. Okay, so whenever you see linear, it's referring to a straight line. And a linear equation means a linear equation is an equation where if you were to draw it, it will always give you a straight line. And an example of a linear equation could be if we have just say y equals 2x plus 1. Okay, the reason why we can identify whether they're going to be linear or not is by their powers. If the highest power of the variable or variables, in this case we have a y variable and it's got an invisible power 1, we also have an x variable and that also has that power 1. Because the highest power of the variables is 1, therefore this is a linear equation. Because if we draw this, it will give us a straight line. Oops, sorry, it just froze. So it's going to be a linear equation. Let's look at another example. So equation 2, if I have x plus 2 to equal 10. Now with this one we can solve it, but as an equation this also is a linear equation because the highest power of the variable, in this case x, is 1. So this will also be a linear equation. Let's look at another one. If I had y equals x squared minus 2. Now you notice the highest power for this one is not a 1, it's actually 2. And because the highest power is 2, this is not a linear equation. It will not give us a straight line. Anything with the highest power being 2, it links to quadratics, and if we were to draw this, we will end up with a parabola. Okay, so that is not linear. So it's pretty straightforward on how to identify whether something is linear or not. And just one more example, if we have something like this, y equals, and just so we have 1 over x. Now it looks like the x is to the power of 1, but it's actually not, because if we were to put this on top, if you remember some of your index laws, if we put this on top, we end up with y equals x to the power of negative 1. Okay, and because it's a negative 1, not a positive 1, this also is not linear. Okay, so for an equation to be a linear equation, it simply has to have the highest power of any variables in the equation, and the highest power is a positive 1. Now the standard linear equation is in the form of y equals mx plus c. Okay, so this is something you have to remember, and it's a standard linear equation. Having your equation rearranged into this form enables you to see the gradient and the y-intercept. Now, remember y and x simply relates to your y-axis and your x-axis. If you were to graph the Cartesian plane, you have a y-axis and an x-axis. So if we extend our graph, it looks something like that, and the origin is at 0. Now, m and c are simply numbers that sometimes we have to find. Sometimes they exist and sometimes they don't. Now, m is the gradient, and that is what we are focusing on today with our lesson. C, you may remember, is the y-intercept. Okay, and we'll have a look at C later on. But just to recap, the y-intercept is where a line crosses over the y-axis, and the point where it crosses over is the y-intercept, sort of like an intersection. And we can also have an x-intercept as well. But today's session is on the gradient. So I want you to, by the end of the session, to have a better understanding of what we mean by the gradient, because it's something that a lot of students do struggle to understand. So we'll be doing some basic examples and linking it to real life examples, and hopefully it will make sense by the end. Now our first step is to define what we mean by the gradient. And what are some other keywords we can use to explain what the gradient is? A common one is slope, or steepness could be another one. You may have heard of rise over run. That's how we calculate the gradient. And one more that I want to add in is a constant rate of change. So constant, it's a rate of change. Rate of change. So the gradient is something that is changing. There's a change between two things, and it can be anything. It could be height and distance on the ground. It could be pay per hour. So the gradient is simply saying, if I was to draw a line, for example, there's a line here, and I'll draw another one, just like that. If we compare these two lines, and I asked you, if you were to climb this line, so we'll draw a person here and a person here, which line will be the hardest to climb? You can tell straight away this line here is steeper, okay? So that's why the gradient is known as a steepness, okay? Or you could say the slope of this line is steeper. So slope refers to how steep something is. Now, constant rate of change. Constant means it stays the same. It's constant. And for example, to link this with a real life example, if you have a job, you get paid a constant rate per hour. Depending on how many hours you work, depends on how much you get paid in total. But your pay is constant. You're not going to get paid, for example, if you go in for a shift, for the first hour, your boss won't give you $50 for the first hour, and then $10 for the second hour, and then for the third hour, maybe $1, fourth hour, $20. Your boss can't do that. It has to be a constant rate of change. Yes, how much you get paid may change per year. As you get older, it might increase. But after that increase has happened, when you go in for a shift, you get paid a constant rate per hour. So that's what that means. It's a rate of change. In that example, a rate of change between hours that are passing and how much pay you're getting. All right, so now let's do another example. So with this example, hopefully by the end of this example, you have a clear understanding on what the gradient is in relation to a rate of change. Now, so the example we're using is, imagine we're climbing a hill, or someone's climbing a hill. Now, I've just drawn a y and x-axis, so our graph. And now the y can represent the height. So just beside the y, put height in meters. That says height, sorry. And x can be distance of the ground, or ground distance, I guess, of ground, and that is also in meters. So whenever you label your axes, you need to write down the symbol you're using, and then of course the units you're using as well. So y I've put is height. Okay, I could have, instead of y, we could put h, but we're just going to stick with y and x for this example. Now, with climbing a hill, now the next part I want you to draw. Well, first let's draw a scale on our axes. So now I forgot to mention, whenever you draw a graph, please make sure you're using a ruler and a pencil. And now I've just put a scale on my axes. For my y-axis, I've got my intervals, you notice, are larger than the intervals on the x-axis, and you're allowed to do that when drawing a graph. Your y scale doesn't have to be the same as the x scale. So my 1 is up here, then 2, and so on. Down here, they're a smaller scale, and I've gone up to 7, and I'll just stop there. So now I want you to draw the same line as I'll be drawing now, and that is, the highest point of this line will be, let's see, when x is 5 and y is 2. Well, I should say hill. And then using your ruler, I want you to just connect that. Now, that's not a straight line, so I'll try again. Now, I've done my best, so imagine it's a perfectly straight line, okay? So you should have a nice straight line doing it on paper. Now, let's draw a person here. So imagine, always different color. Imagine we've got a person at the bottom of the hill, and at this point, it's the origin, so they're starting at 0. So a height of 0, and a distance of 0 on the ground. So at the foot of the hill, and imagine they climb all the way up to the top of this hill, which is just here at the end of this line. Okay, so there's our person. He can have some hair. All right, so now for him, okay, we can name him Bob. For Bob to get to this point, so he started at this point here, and then he ended up here. What two changes happened for him to get from this level to that level? Okay, well, straight away we can see the height, his height has changed. And from this point to that, this point to that point, we can look at the y-axis. He's reached a height of 2 meters. So straight away he's gone up, 2 meters, so above ground. But he's also, if you notice, he's also walked across the ground, and he's walked across 5 meters. So he's walked across 5 meters as well, which is a bit longer than that. Just can't fit it in. So you can see how 2 changes have happened at the same time. So for this person to start from the ground level and reach the top, he has 1, gone up in height, but also he has walked across the ground at the same time. And you can see that's a constant rate of change. And to calculate the gradient, so that will be our next step, to calculate how steep is this line, how steep is this hill. Gradient, which we know m is the gradient, is equal to rise over run. Or another way of saying it, gradient is change in y, so focusing on the y-axis, over, change in x. Okay, rise over run is fine to use, but if you want to put in brackets y and x to remind you that the rise is first of all the change in the y-axis, and then the run is the change in the x-axis. Okay, so that's why we have change in y and change in x. And now all we have to do is to put the change in y over the change in x, simplify, and we have calculated the gradient. So with this example, okay, so from this point to that point, Bob had climbed 2 meters. So for him to reach this point and that point, imagine you're in an elevator, okay, you got to rise up 2 meters. That's a change in y. So far we have m equals 2 meters over, and then your change in x. He's also shifted position on the ground, and he's gone across to get to this point, 5 meters. And we end up with 2 over 5. Now that's a fraction, and that's fine. And to get the decimal, you can just put it in your calculator, and we get 0.4. Okay, and it's depending on the question, you can leave your gradient in fraction form, but putting it in decimal form, it gives you an understanding of how, I guess, large the gradient is, or how steep the line is. Now 0.4 is quite close to 0, isn't it? So you would say it's not a very steep hill, and it sort of makes sense because can you imagine 2 meters is as tall as a doorway approximately, and it's spread out across 5 meters. So it's not going to be a very steep hill to climb, or very long either. Now, if our gradient ever equals 0, okay, that's so if the steepness of a line is 0, then you're expecting somebody to walk across the ground, across a straight line, no rise, no fall, so not even going downhill. That's a gradient of 0. And so you can see how 0.4 is close to 0, so it's not that steep. If we had a gradient of, just say, 10, okay, then you can see the line is starting to get steeper and steeper. And the larger the gradient, the value of the gradient, the steeper the line is. Now, the next thing I want to mention is this gradient, you noticed it's a positive, okay? There's a positive there and a positive there. And that's because there was an increase, okay, in height. Now, if the line, and you can see that how the line is sort of going, up. If Bob, I think his name was, started to go down the hill from this point, so he's reached the top and wanting to go now down, okay, and there can be a 10 over there on the x-axis. If he goes down this hill, it will then be negative, okay? So that's something else you have to identify. Is your line going up or is it going down? So is the gradient positive or is the gradient negative? And that's you determine that by looking at the y-axis. Are the y values as you go up this way, are they increasing? Yes, they are. I've reached 1, now I've reached 2. But now if I start going down this way, so they're two separate lines, going down this way, I'm going down. So not 1 and then eventually y is 0. So the y-axis determines whether the gradient will be positive or negative. And that is something you have to be able to see. So let's do a few examples. So with types of gradients, we can have what we looked at like before. I'll just draw some graphs. Do 4. So there are 4 different types of gradients we can have. And the two most common ones are either positive or negative. So that's positive and negative. And a way for you to identify whether they're positive or negative is, this is the way I do it. Starting from left-hand side, because we start from the left, we go up and then we can go down the hill. So in this case, we're going up the hill. Over here, are we going up the hill or down the hill? Starting from left, that's going up. So this line is going down the hill. That's going up the hill, down. That's why it's negative. Okay? So positive gradient goes up the hill, negative gradient goes down the hill. Now, we looked at the 0 gradient. So if you see a line going like that, that is simply 0. Okay? A 0 gradient. And the last type of gradient we can have is this one here, okay, where it's a vertical line, not horizontal, and this is what we call undefined. And it basically doesn't make sense. And the way to see why it doesn't make sense is because can we both be going up and down at the same time? No, it doesn't make sense to be doing that. We can also use values and numbers to figure out why it's undefined, and we'll do that another time. So these are the types of gradients we can have, and it's something you have to identify. So we've got positive going up the hill, okay, not down. So we're going up the hill. Negative going down the hill. 0, the straight line or ground, and undefined is just the vertical. So let's now practice calculating the gradient. We're given a straight line on a graph. We simply have y and x. This is not related to a real life problem. We just need to find what is the steepness of this line here and this one here, or what is the gradient. Now, our first step is to remember, identify whether it's a positive or a negative gradient. Are we going up the hill or are we going down? Okay? And if you ever get stuck, all I want you to do is that's up the hill and then that's down. So this is going up. And the same with this one, up the hill and then going down. So if you want to, imagine you're drawing a hill, it's a pointy hill, and the person starts from here, up and then down. So this is positive because we're going up. And of course, you can see the y values increasing as we go up. 1, 2, 3, 4, it's getting larger and larger. The y values are increasing, therefore it's a positive gradient. So that's the first thing you must establish and identify. Okay, and so m in this case, for this one here, is positive. We're going up the hill. It's a positive gradient. And now, to do this, all we have to do is pick 2 points and calculate the rise and run between those 2 points, or the change in y and the change in x. And to link it back to the example we did before with somebody climbing a hill, remember on the graph we had starting point at 0, and then the finish point was at 2 meters, okay? So 0 meters and 2 meters. And of course, there was also a change in the ground distance, and that was at 5 meters, okay? Oops, sorry. So just look at your own notes, and you notice that we calculated the rise and run between the point at 0 and the point at 2 meters, okay, for the y-axis. It was between 2 points we were able to calculate the rise and run. So we're doing the exact same thing here. Now to do this, you pick any 2 points you want. Now the points you pick are points that are clearly visible. Okay, so don't try and avoid having, 0.2 or 0.5 and things like that if they're not clearly given to you. Now hopefully this isn't too blurry. Now we can see there are points on this line indicating to us some accurate points. Now, we have a good variety. We can pick, for example, the height, the rise and run between this point here and that point there. Or we could pick maybe the rise and run between this point again and maybe this point. It doesn't actually matter which 2 points you pick, because the rise and run will be the same. And remember that why that's the case. Has the steepness changed at all from here to here? No, it's the same line all the way up, the same steepness, okay? So let's just pick maybe this point here and let's say this point there. And we'll try another 2 points just to prove that the rise and run, the gradient is the same all the way through. Now, we've picked our 2 points. So now we need to work out the change in y and the change in x. Or if you want to write this down, rise over run. And of course, rise refers to the y-axis and run is simply the x. Now, to get from this point to that point, I'll just draw over the points instead of doing a circle, if this works. No, it's not working. Yeah. All right, so there are 2 points. Okay, to get from this point to that point, the way to do this, imagine you are, going to your hotel room, you're on a holiday, and you're on the ground floor. So here's the ground floor with the first point down here. And for you to go up, you have to first go in the elevator and rise up the certain amount of levels. This is the exact same thing. So starting from this point here, down here, we are rising up, looking at your y-axis, so always check your units. So we've got 1, and then 2, 3, 4, and stop there, okay? So now imagine we're on the right level. We have to now walk across our room to our room. And how many, steps do we take? Looking at your x-axis now, it will be 1, 2 steps, and we have reached this point. So imagine calculating the gradient is a journey between getting from this point to that point, but you can't actually walk across this line. You have to rise first, and then you have to run. And the shape you are making by doing this is actually a triangle, okay? And now let's actually work it out. So m is equal to, we know it's a positive gradient. Our rise was 1, 2, 3, 4, and our run was 1, 2, and we're done. And in this case, what's 4 divided by 2? 4 divided by 2 is simply 2. So the gradient is a positive 2. And that's it. And 2 is starting to get a bit larger. Compared to our first example, we had 0.4. So you can see how this line is starting to get a bit steep, or a bit more steeper. And that's it. Now, just to prove that it doesn't matter which 2 points you pick, let's try another 2 points. I'll leave those ones in red, and I'll change the color. Let's see the rise and run between this point down here. It's in blue, and I'll pick this point all the way up here. Now let's see when we travel across our journey, whether we get the same gradient, just to prove it. So to get from this point to that point, okay, see how we are at a -2? You forget about the negatives or positives on the axes. You're simply counting how many units you need to go up and how many units you need to go across. That -2 has nothing to do with what we're doing now. We already know our gradient is positive because we're going up the hill, and that's it. So first step, positive gradient. Now I can forget about negatives and positives. I simply count from this point to that point, how many units do I rise? And let's go 1, 2, 3, 4, 5, 6, 7, 8. So from this point to the same level as the other point, there is a rise of 8. Okay? And now I'm at this point here, and I have to walk across, okay, to get to that point. Now looking at when doing the run or walking across, always look at your x-axis. Now from here to here, is it 1 unit? Yes, it is. So 1, 2, 3, and 4 units. So 8 over 4. And there's our triangle, shape. Okay? And now, what's 8 divided by 4? 8 divided by 4 is simply 2. and we got the exact same gradient. We know it's positive because it's a positive line, and the rise and run between this point and that point was also 2. So you can see how picking any points of your line will give you the gradient, give you the rise and run. And I forgot to mention, you have to make sure the points are from the line itself. You can't just pick a point, just say here, is that on the line? No, it's not. It has to be a point from the line. Now let's try and find the gradient for this straight line down here. I'll just rub off. Now for this one down here, always observe first what is given to you. Now, if I look at my x-axis, straight away I notice it's not going 1, 2, 3, 4 for every interval here. It's skipping one, and 1 unit is one big one here, and another one. And the same with the y-axis. The units are actually larger when I compare it to this graph here. So I had 1, 2, 3, whereas here the 1 is, you can see, is larger. So keep that in mind. And our next step is, do we have a positive or negative gradient? Are we going up the hill or are we going down the hill? We are going up the hill. So straight away, we've established our gradient is positive. So our first step is, for this one here, m is also a positive gradient. Now, we've established that. It's now, we have to simply pick 2 points, calculate the rise and then the run. Done, and that's it. So you can see they've actually given you some points here. They're showing you this point here and also this point there, and they're making it clear to you that that's what it is. And we can also see other points that are highlighted on this line, for example here and there. If I look at this point here, that's where I'm starting to fall into halves. For example, this is, if I look at my x-axis, this will give me 0.5. It's halfway between 0 and 1. So I'll avoid using that. So the safest thing to do is simply use the points given to us, which is this one here and that one just here. Okay. And I'll try and highlight it if it works. Yep. So we're going to be using these 2 points. We know we can pick any 2 points, but of course pick points that are clearly given to you or shown. Now, for us to calculate the gradient, it's simply the journey between this point and that point. But we have to first rise and then we have to run. So, and remember, this is 1 unit and this is 2 and now 3. So to get from this level to that level, we have to go 1, 2 and 3. So a rise of 3. We are now on the same level and we have to go across. Be careful, don't go 1, 2. Have a look at your x-axis. 1 unit is all the way across. So that is just 1. So a run of 1. And we have reached the same point. So m is simply 3 divided by 1 is 3. And that is the gradient for this line here. So just remember to be careful with your scale. And the rise and run makes a triangle shape. Rise and then run. Let's try another one. So for this one, first step is, okay, let's look at our scales. Our y-axis, 1 unit is every sort of, using the grids, the lines, it's 1, 2, 3. So there's your smaller units. Whereas the x-axis, instead of going 1, 2, it's 1 big unit and then another big unit. So keep that in mind. These scales are different. And also now, what type of gradient is this? Are we going up the hill or down the hill? Is our gradient positive or negative? That is our first step when finding the gradient. And you can see we're going down the hill, because if we start from this side, up the hill and then down the hill, we are going down. So when you see that, your first step is to say we have a negative gradient. So our gradient will have a negative value in front of it. And now that we've established it's negative, you can forget about any positives or negatives. We know the gradient is negative. Simply calculate the journey from 2 points. Now, on this line given to us, there are 3 points that are clearly shown. Here, the origin, and just here. So I might just pick the journey between this point and this point. I've picked these 2 points. They're clear to me. I could have picked the origin, but let's just pick these 2. Now, what we're going to do is, what's the rise and run between these 2 points? And that's it. So we have to, if we're down here, we've got to reach the same level as this point there. And to do this, we know it's rise over run. And rise is looking at our y-axis and run is looking at our x-axis. So m equals, our rise is 1, 2, 3, 4, 5, 6, 7, 8. We're at the same level. So that was a rise of 8. And now for us to reach that same point, we've got to go across. Now be careful, don't do this. Don't go 1, 2, 3. Look at your x-axis. 1 unit is all the way across here. Okay, so 1, that's 1, and then 2. Okay, so our run was 2. And now it's a negative gradient, so we're going to have negative 8 divided by 2 is just 4. And that's our gradient. Okay, so just be careful. This one was different for 2 reasons. 1, it was a negative gradient, and 2, the y-axis and the x-axis had different scales. So keep that in mind. Thank you.